Stanford University.
I'm Chana Mannon, and it's been my pleasure to serve with Patricia Sinton Noel as the co-chair of the reunion, and I'd like to say we take all the credit, but the real credit goes to the Alumni Association. They have a very firm framework that helps you do your job. But there are a few people that have been invaluable, and I think the two people who had the hardest job were Verity Cook-Powell and Jeannie Hertz. Could they stand up? They were the ones that got all those people to call you and say, come to the reunion, whether you talked to them or they left messages on your cell phones. So thank you all, Verity and Jeannie. And the other three people that I want to especially thank are the people that have coordinated mini reunions. Now there are the official mini reunions tomorrow night, and I think it's so funny, having been a Branner girl, that they're serving alcohol in the Branner dining room legally. And I know there are a bunch of other Sub Rosa reunions as well, but Benny Chen, Edie Dunn Freer, and Kent Hinckley, if you're here, stand up. Thanks for getting all those groups together. Benny's in the back row. So with no further ado, let me introduce you to, I think you all know Patricia, because she was your chair last time as well, so.
I too have some people to thank. I want to thank our two writers, Sharon Fogelman Hawkinsmith, who is the communications chair for this reunion, the events part of this reunion, and Joan Ferguson Peck, who is our class correspondent, and you see her name in the alumni magazine. If they're here, if you're here, will you? Thank you so much. Peter Steinhardt, who is our class book editor. I think probably each one of you has seen the class book, and it mirrors, to my mind anyway, it mirrors Peter's intelligence and creativity and general all-around wonderfulness. Peter, can you stand up? We have two panels. Peter Steele is leading the Sunday class panel, Sunday at Jimmy V's on campus, 9:30 breakfast, 10 o'clock to 11:30 the panel, and the title is Life Part 2, What Comes Next? And if that isn't something that we're all curious about, I don't know what is. So Peter, if you're here, could you stand? There you are. And I want to thank and introduce John Bryson, who is the leader of today's panel on climate change. I would like you to take a look at John's bio in your program. And I want to, of this very impressive bio, I want to highlight two aspects of it that show his dedication to environmental issues that spans over 40 years. The first is that at 24, with 3 other Yale law students, John started the Natural Resources Defense Council, the NRDC, going strong and saving environments today. Absolutely fantastic experience. And then, jumping way ahead, at 67, is that right, John? He is
People in this group probably can estimate my age very nicely.
I was guessing.
Right on the money.
So at 67, he is one of 14 members of an international United Nations panel advisory committee on climate change, and they report directly to the Secretary General of the United Nations, Ban Ki-moon. So John is obviously eminently qualified to lead a panel on what is probably the crucial issue of our time, climate change. John Bryson.
Thank you. All right. Well, You know, we're enormously flattered that so many of you would have come to this panel, and I hate to have any of you have to stand. I mean, I do see some places. Don't hesitate. I mean, it's going to be a little hard to stand throughout. So come forward. So, you may have heard or seen me floundering around a little bit to place a cell phone call, and you may notice a so far empty spot at the front panel. Hopefully Chris Field will be here. He was to make the initial foundation set of remarks, and I'll tell you what he hopefully will talk to. I trust he'll be here. Chris is not a member of our class, but he is an extraordinary member of the staff or faculty. And to set the foundation for a talk, for a dialogue, and we hope it'll be a dialogue, a debate, and engagement with all of you, my vision, Patricia asked me to do this, and then she would periodically send me notes saying, how are you coming? How are you coming? And I was a little slow, but I went into action. And Chris, so most of you, or those of you that follow this area will know about the IPCC, that's the United Nations large group of scientists around the world that have addressed climate change over these last decades and under the auspices of the United Nations. Chris plays an enormously important role in that. He heads one of the three groups of scientists, and for example, I was reading the New York Times on a climate change related issue just in the last about 8 or 10 days. Chris is the person who now has the lead responsibility within the IPCC to do something that they've got to do, and that is assure that there is nothing ever presented by any of these scientists that for the sake of simplifying, which is the way they may see it, or otherwise advancing responses to climate change that isn't pure, unquestioned, excellent science. And for the most part, it has definitely been that. But there's been, as some of you would likely know, there's been a very big tack on climate change science. And we can't have that. I mean, the policy, anything that so mostly what I've worked on is policy. But science is the foundation. So we've got calls out to Chris. Hopefully there isn't a mistake. Hopefully he'll be here. Putting together the panel was a lot of fun, and I want to turn next to who may become our first speaker, Al Hammond. And we're not bad. We can kind of kick this back and forth and advance the ball along if Chris doesn't show up. But so I looked through our class book. All of you did that to some degree. You know, it takes a long time to read through all these to see who might serve on this panel. And there were various candidates. But Al stood out for me because of so we were at Stanford, Germany together. It was a kind of, I think, a particularly close group of people. It was a special 2 quarters for us. It was the time of the Kennedy assassination when we were there and so on. Anyway, Al went on after Stanford, got his PhD in a subject he can describe to you better than I can, did science journalism for a decade after getting his PhD, has written something like 15 books, has done vast numbers of peer-reviewed articles, important articles in premier journals, and became moved some 20 plus years ago to move in the world of social entrepreneurship. So he's done this most recently through Ashoka. It's extraordinary work. He calls himself a serial social entrepreneur. I think he'll be fabulous. I believe that all along. We talked, sent emails back and forth. He said, I'd love to be there, but I am in Southeast Asia, and I couldn't possibly be at the reunion. After a while, we worked that out, and he's here, and he came in yesterday, is that right?
This morning.
Came in this morning. So,
I'm going back tomorrow.
So, I mean, this is what I call above and beyond the call of duty, but it's pretty wonderful. And so going through the book, Bill was in the Arroyo house with me as freshman. His entry in the class book is terrific and funny and so on, and he says he kind of blew it as an undergraduate because he really didn't spend any time really reaching out because he was so involved in being an electrical engineer, and it screwed up his social life. You know, that's a problem, right? He's remedied that, and I don't mean it that way. He has a long time and wonderful wife, and they live in Juneau, Alaska, and electrical engineer and lots of work on improved energy systems, electric systems. And he does have a wind machine, for example, near Palm Springs, California, that in his notes he said, let's see if I've got this right, he climbs the towers and rebuilds gearboxes on this 1985 wind generation, which happens to sell the output to our former company, my former company. It's sort of a long time for me, Southern California Edison. So they will both have terrific things to say, and then I will have something to say too. I'd like to talk to some of the things that I've been involved in and care a lot about. So the three of us will march down the path, and hopefully Chris will show up. So,
Okay.
yeah, whatever.
Well, so just assume you've had a talk about how serious climate change is and deep into the science, and we've all sort of registered that framework. Because I'm going to talk to you about the people for whom climate change is not yet an issue, but are probably the most vulnerable to it, which are the 4 billion people that live in relative poverty around the world. And furthermore, we care about their energy strategies, because if they even doubled their use of energy, which they will, and that came from fossil fuels, it would swamp all of the industrial countries put together. 4 billion people is a lot of people. So, but what's interesting is that not only are lots of high-tech companies and venture capitalists putting money into better energy solutions, but so are people called social entrepreneurs working in these low-income, I don't like the word poverty, but low-income communities. So I'm going to talk to you a little bit about that, just because I think it's interesting that that kind of innovation never makes the front page of the Times, but it may be as important as whatever happens here in Silicon Valley and other places like that. So, and I'll just start by showing you this picture. I'll come back to that. But that's in a community in northeast India that is beyond the reach of the electrical grid. And it is a gasifier for rice husks, of which there's an enormous quantity in India, and they're normally thrown away. It gasifies it, it runs it through a generator, and it creates a microgrid so that the people in that village can have power. And this is not a charity, this is a profitable business. People pay for power. If they don't pay it, they turn off the machine and truck it away, which they had to do once. But they already have 50 of them up, and they will probably have 500 of them up in another few years. So it's an example of the kind of thing that can be done. So let me, if I can figure out how to advance this here. Let's try this. There we go. So, yeah, sure. So this is the money that these 4 billion people spend and what they spend it on. And you can see most of it's spent on food. But the next biggest thing is energy. A lot of that's what they pay for. It doesn't count the wood that they gather or the cow dung. But nonetheless, this whole market of 4 billion people spends $5 trillion a year out of pocket. So if we could tap that as a market, We could do a lot of things, and that's exactly what's starting to happen. So the most important energy innovation is a more efficient way to cook your food. That's what dominates the lives of a lot of women in particular who have to gather that fuel. And in fact, some of these stoves, and there's lots and lots being tried and explored, but some of them do things like pelletize the fuel, whatever kind of biomass it is, and then burn it in a stove that's 6 times as efficient as an open fireplace, and smokeless, because the smoke from burning wood in a enclosed space is pretty bad for people's health. So this is a really interesting set of innovations. I'm not going to talk about them in detail. The next one comes a little closer to home, because now we're talking about electric power. So there's solar home type things. There's things for industrial customers, particularly cell towers and things like that that are out in rural areas. And then there's community scale things. So let me just mention a couple examples here. There are 2 companies. One is called D-Light, which was actually incubated here at Stanford. And the other is called Husk Power, which started in Madagascar. And they build things called solar lanterns. It's a teeny little solar panel. And connected to it is an LED light and a little battery. And a couple of other connections so you can plug in a small radio or recharge your cell phone. And these now cost about $10 or $12. Well, with a little credit, poor people can actually afford that. And they can get 3 or 4 hours of light in the evening at a much cheaper price than a candle or a little thing of paraffin, and of course, much better light. And they can recharge their cell phone, which is critical for many people. So this is, and these 2 companies, and they're both for-profit social enterprises, this last year each sold over 100,000 units. And they're just getting warmed up. Now, you might even want to buy one if you're going camping. It's much better than that kerosene stove and hauling around that nasty fuel and all that kind of stuff, right? I won't say too much about the commercial systems because they're a little bigger and they actually don't look too much different than the kind of thing we're building in this country. But let me just give you an example of how important it is. In India alone, they built 100,000 cell towers last year, most of them in rural areas, and they're all powered by diesel generators, which have to be serviced and fueled every month. And in fact, the cost of taking care of those diesel generators, including the fuel, is more than 50% of the cost of running a mobile phone company. So, not surprisingly, the mobile phone companies are very interested in going green because it will add green to their bottom line. So people are starting to serve that market. But let me talk a little bit about Husk Power, which is the company in India, and a similar company called AEDS, which is in South Africa. So the gasification I've explained, and they typically sell the power for about a nickel a kilowatt. So that's, you know, getting down to what, it's actually less than what you can buy solar power for and these kind of things, although the PVs will probably get there eventually. So this is a very affordable solution. And these people have absolutely no source of electricity. They're off the grid. And just to give you a sense of the magnitude, there are about a 1.5 billion people with no access to electricity. And another billion for whom the grid is so unreliable that it effectively doesn't exist, right? If you're growing crops and you can't pump today and it's 120 degrees, well, by the time it works tomorrow, you may not have a crop anymore. And if you have to go to bed when the sun goes down, then you're not going to do too much homework in the evening, are you? And that's the way a lot of people live. So we've got over 1/3 of humanity that doesn't have access to electricity in any reliable way. And yet, if you look at the correlation between electric power and GNP growth, as John probably knows very well, it's tight. It's one of the single most important things to increase a people's productivity. And for these people, higher productivity means better quality of life. higher incomes. So the other one is equally interesting. This is around something called, I don't have a picture of it, called a zinc air fuel cell. Sounds extremely high tech, but you can think of it as a kind of a dry battery. And you put a sheet of zinc in it, and it generates power, and with a switch that you can turn on and off. So in South Africa, most people who live off the grid instead burn paraffin. And they spend typically about $30 a month on paraffin. This company provides you this zinc air fuel cell and a supply of regenerated zinc sheets for $20 a month. It costs $100 to buy the device, which they will loan you money for, and they're actually subsidizing that. It really costs $200, but it's sort of a give away the razors and sell the razor blade kind of model. And this power can run a light. It's enough power you can run a sewing machine. You can run a TV. So it's a very good solution. And at $20 a month, it's actually affordable for lots of people. In fact, I plan to get a couple and put them in my basement for the next time the grid goes down. Because they sit there doing nothing for a very long time, and then there's power when you need it. And there's no acid or other messy things in the thing. So these kind of solutions, some of which are fairly technological, as you can see, but even more importantly, the business models to figure out how to do it efficiently, what people can afford to pay, how you actually engage a whole community. In this South African case, what they do is they don't build it until, they don't move into the community until 90% of the households have signed up. So then it's a community-based solution. So those are the kinds of things that are going on. And I think it's an enormous cause for hopefulness, because these kind of solutions are happening not just in energy. I'm doing some things in healthcare. Other people are doing things in quite other sectors. And in a funny way, as my former colleague C.K. Prahalad once said, the base of the economic pyramid is actually the innovation lab for all of us, right? There's no legacy systems to fight against, right? So if it works and you have an immediate market that's cost sensitive, and if it doesn't work, you don't have a customer. It's that simple. So, and so that's starting to take off, and the explosion in social entrepreneurship in the last couple of decades has been sort of enormous. And we find 1/3 of business school students want to do this if they could figure a way to pay back their loans. Right? So I'll start up and turn it over to somebody else.
So we're going to come back to questions and dialogue, but Bill will go forth next, and we'll improvise beyond that.
At this point in our lives and careers, we should all be waxing philosophical. I intend to, after I have disclosed the profound environmental influences on my life. I grew up in the First Congregational Church in Waterloo, Iowa. I was a high school science fair nerd. With my BSEE from Stanford, I got a very good job with Collins Radio Company as a marketing engineer, followed by 13 months in Southeast Asia, Thailand and Vietnam as a field engineer. Back to GSB for an MBA degree, and then north to Alaska. I was a contract budget analyst for the state of Alaska. Then I bought an outdoor salmon bake restaurant for $750. Sold that, put all that capital into a small wind plant, selling energy to Southern California Edison. I do climb the towers and fix these things. It's good, honest work. And then, founded by my father, the last 10 years I've been pro bono for a small charitable family foundation, the Leedy Foundation, co-authoring papers on a particular aspect of the energy nexus, energy climate change nexus. Alternatives to electricity for transmission, storage, stranded, that means far from markets with no transmission, renewable energy resources, and the alternatives that look most attractive are hydrogen and ammonia fuels, carbon-free fuels via underground pipelines. They are the only fuels that are carbon-free. Now, electricity is the obvious way to get wind power from North Dakota and desert concentrating solar power to major markets, but there may be a better way, and I've been trying to find it. Global warming is real in Alaska. 1971, when I came to Juneau, this is the Mendenhall Glacier. This is it today. 71, today. All of that terrestrial ice has turned to water, run into the ocean, raising sea level about 3 millimeters per year on the average worldwide, contributing to that. It's not the only course. Warmer winters, the spruce bark beetle gets a reproductive advantage. It's wiping out the forests of Alaska. Where there's permafrost, the permafrost melts, the trees fall over. The Chukchi Sea ice pack goes out earlier now because of warmer winters, exposing the coast to the remaining winter storms, which erode it. Over the next several decades, about a dozen Alaska villages will be erased from the surface of the earth. So these profound environmental influences upon me have caused me to conclude that we must run the world on renewables. Excuse the vernacular, but run means to do or to make the things that we humans want. Because this spaceship's only source of income is energy from the sun, a little bit of tidal action from the moon, and some debris, we are in the process of spending our capital, including the natural capital of this biosphere. So that's why we must run the world on renewables. We only have 200 years of coal left. Peak oil and peak gas may be in our lifetime. Why don't we leapfrog this and run the world on a combination of distributed, that means the PV panel on your house and mine, and centralized, the big wind plants, the big solar plants that are stranded and require transmission and firming storage. Why don't we do that? What's the problem in responding to this climate and energy problem before us? When we regard these as emergencies, or even several of them, whether you believe in climate change or not, or whether humans are causing it, when these become emergencies, we want to quickly invest in conservation and efficiency, where we get the best return, the fastest, and make the most jobs. Then very large-scale renewable energy production, both distributed and centralized. To do that, we need to think beyond the electricity grid. We can't do it all with electricity transmission and storage. And that's where hydrogen and ammonia alternatives seem attractive. Now, what's our problem in responding to this global threat of climate change and energy, this energy-climate change nexus? Haven't we always thought that a killer asteroid or an alien invasion would unite the human community? Why are we bickering with each other, fighting wars, wasting resources instead of pulling together to solve this climate and energy problem? If Rachel Carson was the mother of the modern environmental movement, Aldo Leopold was probably the father. In the 30s, he wrote about 2 spiritual dangers in not owning a farm. And in the 30s, owning a farm meant you grew your own food and you chopped your own wood, supposing that breakfast comes from the grocery, heat from the furnace. You remember the 6-hour PBS series by Bill Moyers and Joseph Campbell about the power of myth, where Campbell asked over and over again, what myth are we living? Now the philosophical part. I think we are living an old myth, anthropocentrism, anthro-exceptionalism, which then leads to ethno-exceptionalism and American exceptionalism, which we see among us today. And my metaphor for that is something that's almost 100 years old. It's a World War I German army belt buckle. It says, Gott mit uns, God with us. God is on our side, not your side. I think this is a metaphor for the fundamental human problem that prevents our adequate response to climate change and the energy problem, that nexus. Because I think since we became sapiens, we have believed that since we're apparently the most powerful, intelligent species on the planet, that we must be God's favorite species. Therefore, God won't let us fail. God won't let catastrophic climate change happen. God won't let us run out of energy. We don't need to take individual responsibility. And I think that describes our situation today. It's an old myth. We need to get beyond that myth. So excuse me, I don't mean to be pejorative or blasphemous or cute about this, but that's my complex, the result of the environmental influences that have happened to me. And I think it's not just Judeo or the Abrahamic religions. I think it's fundamental to the human situation. So let's begin a new myth for energy and climate change. This is the total world energy use per year. This is the total input, renewable source energy per year. This is capital over here. We need to transition from this, spending our capital, to this, running the world on renewables. There's plenty of renewable source energy if we can just generate it and get it to the right folks to supply all the world's current energy use. Consider wind energy, which happens to be the most popular and the lowest cost renewable at this time. There's enough wind energy in these 12 states, if fully harvested and delivered to market, to run the entire country's energy economy, not just electricity, all the energy in this country. Look where it's concentrated, stranded, far from markets, no transmission for it. There's 3 orders of magnitude more solar energy than there is wind energy, and there's enough wind energy to supply all 100 quads of the energy consumption in this country at this time. Fortunately, they're both synergistic diurnally and annually, and so combined in transmission that minimizes the amount of storage we need to deliver firm energy, which is what we humans want. We want the lights to always go on and the factories to always hum. Now, the American Wind Energy Association says by building this much new transmission, we could supply 20% of our electricity from wind by 2030. But electricity is only 1/3 of our energy. This is a lot of transmission. It's expensive. You and your green neighbors are going to fight a lot of these things for decades. Some of it may never be built. So electricity transmission for large stranded renewables, if we're going to run the world on renewables, has some fundamental problems. It's very expensive per unit of transmission, which is the gigawatt mile. NIMBY problem, once you get the energy to Southern California Edison grid, they have the problem of integrating this time-varying output. The wind stops blowing, the sun goes down. How do you integrate that? A dedicated transmission line is going to have the same capacity factor, or a fraction of that line, to the renewable source, typically 30 or 40% capacity factor. There's no affordable firming storage for annual scale of these renewables, vulnerable to acts of God and man, including cyber attack. It's just not a good match if we really are trying to run the world on renewables. Now the smart grid is the next big thing. By making the grid smarter, do we just make it more vulnerable to cyber attack? It doesn't add any physical transmission or storage to the system, making the grid just smarter. And so we need to think of complete integrated energy systems. And somebody in that corner is standing right in front of this little energy system. If you would be kind enough to bring it up and set it on the corner of the table, I'd be very grateful, because he's going to take it away from the artificial sun, the source of photons for its energy input, and bring it up here and demonstrate perpetual motion in this very room. So the hydrogen alternative looks like this. At the wind plant, we change that energy from electricity, no connection to the grid, through electrolyzers, and ship hydrogen to our markets. We store it here and in very large, low cost. Just stick it on the corner of the table up there, it'd be great. Thank you. You can see that the sun has gone down, but we still have work being done, which is what we humans want. We want work, whether it's turning a propeller or lighting the lights. So either we have perpetual motion here, or there's storage in the system. And this is a hydrogen storage system. There's hydrogen in this room, and we're all still in relatively good health. So this is what the hydrogen transmission and storage system would look like. The storage, very low cost, 16 cents a kilowatt hour capital cost for storage. The recent ARPA-E solicitation for advanced storage systems, the goal was $100 a kilowatt hour capital cost for electricity storage systems. If you can contemplate complete energy systems based on hydrogen or ammonia, we get very low cost, very large scale storage so that we can supply firm energy from these renewables. And then when we bring it in from North Dakota or the western deserts to the Bay Area, we distribute it for vehicle fuel and for combined heat and power in residential or commercial buildings. You Californians can lease this vehicle now. Hydrogen fueled, fuel cell electricity, and the lease includes free fuel. Now you can lease that vehicle. Does it make any sense to contemplate, in addition to or instead of this electricity transmission grid, collecting all this abundant renewable source energy, solar and wind, as hydrogen, shipping it to the major markets in underground pipelines, including down to where we have the very good geology for salt cavern storage. Does this make any technical and economic sense? We don't know. We haven't done the studies. We need to build a pilot plant to bring diverse, renewable source energy as hydrogen gas to a destination community, maybe Ames, Iowa, Grand Forks, North Dakota, to see if this makes technical and economic sense. Otherwise, we don't have this alternative available to us if we haven't demonstrated it. Anhydrous ammonia, NH3, is the other hydrogen. It's also a very attractive fuel. Even for Village, Alaska, if it works in Village, Alaska, every village, every community in Alaska is an energy island. It should work in India and other parts of the country, of the world as well. And at large scale, we've been using it to run internal combustion engines in the 30s and 40s and rocket fuel in the 60s. It's a fuel, it's a carbon-free fuel, very high energy density, and engines run very efficiently on it. Here's an internal combustion engine turning an irrigation pump, and here's a hot rod engine running on ammonia fuel, no carbon. Can be made from renewables. Very inexpensive storage, 8 cents a kilowatt hour compared to $100, which was the DOE goal. And if we make it from renewable energy sources and liquefy it, we can ship it around the world as we now do. There's a major trade globally in anhydrous ammonia, mostly for fertilizer, but it's also a fuel. And both hydrogen and ammonia are simply off the charts in any measure of electricity storage, which we're accustomed to talking about, batteries and flywheels and compressed air energy storage, months of storage. If we can contemplate, whoops, no perpetual motion. Our system has run down. It's exhausted its hydrogen energy supply. The fuel cell is out of fuel. But that's a model of the complete energy systems that we need to be contemplating. Here's the comparison of the capital cost of electricity, including this new announcement by Google for an Atlantic wind connection subsea cable, $2 or $3 million per gigawatt mile of capacity. Hydrogen or ammonia pipelines are about 1/10 of that. And they're underground, under your backyard, not over your backyard. So our response to climate change fundamentally must be a new myth and a commitment that, a vision that we need to run the world on renewables. To do that, we need to think and explore beyond just electricity transmission and storage. Our identification, our loyalty needs to be with the whole living planet which we inhabit. And we have to take responsibility from which hope will ensue. There are plenty of indications that all the indicators are going the wrong direction. But we have to take responsibility and have hope. You don't need to believe that climate change is a problem or that humans are causing it, because there are many other reasons why we want to run the world on renewables, convert the world's largest single industry, energy, from fossil fuels to renewables and some degree of nuclear. It's very hard to predict how much nuclear is going to be important in our future energy system. Can we Americans still be counted on to do the right thing? In order, we need a new myth, a new commitment, a new vision in order to do that. I do have some DVDs of conference presentations available if you want to get deeper into this. Thank you very much.
All right. Chris Field.
Thanks so much. You're very generous and kind, allowing me to sneak in late like this. I'm just going to pop a different computer on there.
Oh, okay.
I want to talk to you for just a couple of minutes about the velocity of climate change. You know, we can have lots of discussions about whether or not climate's changing, what the kinds of strategies we should be deploying. And I want to talk about the temporal dimension of all of this. So why do we need to think about action now rather than with a few years of delay? And what kind of evidence would we need in order to make good decisions about energy system for the future? My goal in communication, I guess I'd like to be as good a communicator as Winston Churchill, but I'd even settle for being as good a communicator as Tom Tolles here, who says in 2060, finally, we've got the breakthrough concept for climate change. And instead of a perpetual motion machine, this one's a time machine, and it takes us back to 2010 when we should have done the right thing about action on climate change. So I want to explain why this is so important and prescient. In order to do that, I want to start with Article 2 of the UN Framework Convention on Climate Change. This is kind of the general guidance that the world adopted in 1992 about the way we ought to be addressing issues of climate. It really has two components that are important. The first is that our goal should be to avoid dangerous anthropogenic interference with the climate system. Talk a little bit about that, what that means. I think there's also something that's kind of misleading about this concept, and the idea is that we're safe until we hit some amount of global warming, and then we have big problems after that. The way you need to think about climate change is that it's much more an issue of balancing risks, the same kind of risks that people take when they invest in the financial markets, when they buy a home, when they decide about how much insurance to buy for their car. And once you take a risk-based perspective, it's much easier to think about what are good investments in conservation, efficiency, new technologies, or carbon capture and storage. The other component of Article 2 that's really important is this one about the pace. It says we need to act in a time frame that protects resources that are important, that protects not only natural ecosystems, but our ability to produce food, and perhaps most importantly and most challengingly, to preserve the possibility of sustainable economic development, which of course is a two-edged sword. If you invest too much in addressing climate change, then you don't have enough resources left over for addressing sustainable economic development. And if you address too little in climate change, then you have the impacts of climate change that are then suppressing the options for sustainable economic development. So how is it that we find the middle way? And I think the real key to this is understanding that climate change is a problem that is intrinsically one of managing risk, something that in general the world is really, really sophisticated at, and once we start applying the sophisticated risk management concepts that are out there and well embedded in our culture, we can do a much better job. Now, let me present three quick analogies about ways to think of the risk. My colleague Steve Schneider, who tragically died a few months ago, liked to talk about climate change as like playing a game with loaded dice. And as we put more and more heat-trapping gases in the atmosphere, we were increasing consistently the probability of getting the dice combinations that were unacceptable outcomes. And that highlights the concept of risk, but it doesn't capture a couple elements I want to communicate. John Holdren, who's the president's advisor on science, talks about climate change is like driving a car through the fog, and there's a cliff out there somewhere, but you don't know where it is, and what kinds of action should you take in order to make good decisions about not driving off the cliff, about not having a disaster that's related to climate. And this also captures the essence of risk management, but again, it misses a couple keys that I think are important to thinking constructively about this particular problem. And I want to introduce a new analogy. We live in a global economy that you can think of as a truck that's driving along the highway of life, dumping nails along the road. And we're all following along in our vehicles, and some of us have fancy ones and some of us have simple ones. But the more these nails get dumped on the road, the more risk there is of the cars that are following behind getting flat tires. And for some of the people, the flat tire is going to be a little inconvenience. For some people, it could result in an accident, and for some people, it could result in a catastrophic accident. The more of these nails there are, the more risk of an accident there is. And the more accidents there are, the more risk there is of catastrophic, truly tumultuous pileups that involve many cars and situations where even if we had the best tires and the best driving skill, we couldn't have avoided. And that's what I think climate change is really like, that we're creating a situation in which we already have produced dangerous anthropogenic interference in the climate system for some of the stakeholders. It's probably not the people at this reunion or the people in Northern California, but for some of the world's people, we are already seeing impacts, and they are having profound effects. The question is what makes those profound effects spill over into other sectors and other parts of the world? And it's a very hard question to answer, but I think the answer lies in the way that the effects get transmitted through the society. I also like the dumping nails on the road analogy because it highlights the three major strategies we can think about for dealing with climate change. The first thing we can do is we can go out and we can buy super nail resistant tires or really big bumpers for the car. That's the adaptation strategy. That lets us drive over all the nails. We say, well, we can't prevent the climate change. We'll just minimize the impacts that occur to us. And that's an okay strategy, especially if you have the resources to purchase the protective equipment. If you don't have those resources, adaptation does not look very attractive. The thing that we talk most about, where the opportunities in new energy technologies are, is in mitigation. That's slowing the rate at which we put the nails on the road and maybe figuring out ways to take some of the nails off the road in the future. And I think it's clear that in the long run, that's got to be a core part of our thinking. And then it also is an increasingly important part of the international dialogue to consider strategies that are called geoengineering, trying to reflect back some of the solar radiation that's causing the heating that we're struggling with, and masking the problem of climate change rather than genuinely solving it. I think of this as sort of laying a piece of paper over the nails on the highway. The first couple of cars may be fine, but pretty soon the paper's gone and the problem's back to where it was. So the geoengineering fix is one we don't understand very well, but based on what we do understand, it should be viewed as a momentary way to mask the problem and not a real solution. So what should we do, given that climate change is a problem of risk? It's a problem where we're already seeing impacts that are having important effects in some parts of the world, and where, as we understand more and more about the impacts that are occurring, we get a better and better picture of the way these impacts tend to interact with each other, spread out of the places where they start, and have the potential to interact with each other in ways that become potentially global in scale. So I think the answer to this dangerous anthropogenic interference question isn't that the world is safe at a CO2 concentration of 350 parts per million, but it has surpassed a critical threshold at 450. It's that we're already seeing significant impacts of climate change, and that there's real value in making smart investments in new energy technologies, as well as in adaptation and learning more about geoengineering, so that we can make thoughtful, constructive, hopefully win-win decisions about dealing with climate. I'm going to skip a couple of slides because I want to just say one thing about the dynamic of moving toward effective solutions on climate change. I apologize. I was late in here, so there's not going to be a quiz, I promise. So, you can think that the basic goal in dealing with climate change is to prevent dangerous anthropogenic interference on a timetable that makes sense in the context of the UN FCCC Article 2. And I see us basically at the point where we've kind of identified what we want as desired impacts. We want to stay below this level of dangerous anthropogenic impacts. And we have some kind of a goal. But what we need to recognize is that it takes time to develop the solutions. First, we have to recognize that there's a problem. We need to come up with whatever international agreements or national scale agreements we're going to use in order to create a level playing field or to create opportunities for the technologies we want to favor. We have to make time to develop those technologies, in particular to drive the prices down so that they really are competitive with the existing technologies. And then we have to take time to allow those technologies to diffuse, because a really, really important part of the climate change dilemma is that even though historical responsibility for the concentration of heat-trapping gases in the atmosphere rests with the developed economies in the northern hemisphere, it's increasingly the rapidly developing economies in Asia that are responsible for future emissions, and they're going to be piled on by economic development, legitimate economic development in Africa and South America, where what needs to happen is that economic development needs to be powered by the technologies that aren't increasing the problem. So the challenge we face is that we can see a series of events where the actual impacts have the potential to be substantially greater than the impacts that we'd like to have, not as a consequence of being slow in recognizing that there's a problem, but being slow in recognizing that the solutions take a lot of steps, complicated steps that involve people all over the world. It's also important to recognize that the climate system isn't sensitive just to the things that we do, that there are natural feedbacks as well, and we're working hard to understand which of these natural feedbacks amplify to make the problem worse and which kind of suppress to make the problem not as bad, and we don't have a very clear understanding of that. the reason that the velocity of climate change is so important is that right now we're at the stage of having recognized the problem, but we're not at the stage of having effective strategies for implementing all the steps that need to be taken to get from where we are now to a global deployment of the kinds of strategies that you just heard about. I like to think of it, well, this is 25-year-old Gary Larson cartoon, and he said, you know, dinosaur talking to dinosaurs, it's really bad out there. We not only do we have the climate changing, but our ability to think through the kinds of solutions we need is really limited. So this was 25 years ago. I should say that even 20 years before that, in the mid-60s, people understood that the climate change problem was one that we needed to get ahead of and needed to think hard about. But in 2010, I think we're in a somewhat different situation where the debate has really been reoriented, and the forces of doubt in climate have really have been very, very effective over the last decade, so that much more in the media today you see this message than the message in the 1985 Gary Larson cartoon. And you know, the critical thing to remember is that there is a lot of uncertainty in our understanding about climate change. There's no uncertainty about whether climate's warming. There's no uncertainty about whether it'll warm in the future. But the extent, the spatial distribution, the extent to which we'll see changes in extremes and disasters, there are a lot of uncertainties. And the real question is how we manage those. And I want to just close with one more cartoon, but it's a cartoon that captures my vision of why we really should be dealing with climate change and why we should be dealing with it now. So this was a cartoon that came out during last year's Copenhagen Symposium. And you know, the kinds of things we need to do, well, you get the point. It's not hard decisions to strive for energy independence, to strive for vibrant rural lifestyles, to strive for cleaner air, and if we can solve the climate problem at the same time and prevent dangerous anthropogenic interference, why not do it? Thanks very much.
All right, I'm going to give up my time here because I feel proud of a lot of things that I've been involved in. I'd happily talk about them a little bit. But our three speakers have been so extraordinary, so extraordinary. What I thought I might do is just be a little bit of a moderator, and you know, I may chip in a few things as we go, but I won't give the remarks I plan to, because it's no treat to sit there for a very long period of time and not be engaged. So what I want to see is all of you engaged by putting questions, making comments to our panel. I'll chip in something if I want to.
Well, thanks, John, for the question. The IPCC is an amazing partnership between the world's governments and the scientific community. And over the past 22 years now, it's provided the definitive evidence for what we know and what we don't know about climate change. And one of the things that's really striking about the results of IPCC is that it's very, very explicit about the things we don't know. And I think that the risk framing that I told you about earlier is really incredibly fundamental to the way the IPCC presents information. What's so unique about the partnership between the governments and the IPCC, the members of the IPCC are the world's governments. And essentially what they have done is gotten together by consensus and asked the scientific community to work with them to present a clear picture of the climate change situation and what are our options for dealing with it. The IPCC has produced 4 major reports and a number of more compact reports in 1990, 1995, 2001, and 2007. And as you probably know, it was awarded the Nobel Peace Prize in 2007 and has really been attacked really viciously over the last year or so as a consequence of a couple of errors that were in the 2007 report. I think that what people need to understand about the IPCC is that it's really the the partnership with the governments and the review process that gives us its power. It gets thousands of scientists together to sort through the information that's in the literature. It sends the chapters out for extensive reviews. It's a requirement with an independent review monitoring process that the authors of each chapter respond to every review comment individually, that they comprehensively treat everything that's out there in the scientific literature. And it's very difficult for things to get missed. Unfortunately, the errors in the 2007 report showed it's not totally impossible. But then what's really impressive is that the summaries for policymakers, which are sort of 20 to 30 page documents that have most of the conclusions you will have seen from the IPCC, are approved by consensus, word by word, by every one of the world's governments. So if we were working on approval of a summary for policymakers and the statement was warming is unequivocal, which is a statement in the 2007 report, I would put the statement up on the board behind me. There'd be a group of country representatives with about as many people as there are in this room, and we wouldn't move off of that statement until every country had agreed that that was an accurate reflection of the science underlying it. It's an amazing process, and it's amazing that it works at all. My role in the IPCC is that beginning in 2008, I took responsibility to co-lead the part of the IPCC that deals with impacts of climate change, adaptation to climate change, buying the big tires on the truck, and vulnerability to climate change. Who is it? Who's sensitive? Where's the sensitivity? What kinds of ecosystems and what kind of animals? And we're working on two projects right now. The project that will be completed in about a year from now is on climate extremes and disasters, the way those change with climate change and the implications. It turns out that the vast majority of the economic impacts from climate are in disasters like heat waves or hurricanes. And trying to figure out how much of a link there is with climate change has been a top priority. And the second thing we're just starting to work on now is what's called the fifth assessment report, where we'll do a comprehensive analysis of everything we know about impacts, adaptation, and vulnerability based on scientific literature over the last 5 years. And that product, you don't need to sit on the edge of your seats because it's going to be 2014, but we think it will really provide the kind of information that stakeholders at every level, that governments, that the private sector, and even individuals need in order to make good decisions about dealing with climate change in the future.
All right. Come forward. Who has? Yes. Would you help all of us by introducing yourself so we should know, but you know, it's been many years. But it's sort of fun for everybody in the room to, yeah.
My name is Ken Hinckley, and I'm just curious if... My name is Ken Hinckley, and I'm just curious until we get to the renewables, if there's a possibility of using thorium as an energy source.
Actually, I can talk about that. Yeah, there, in fact, is, for the first time in several decades now, some new work going on nuclear fuel cycles. And it turns out that there are more possibilities than the light water reactor that was originally developed for submarines, which is what we've been using ever since. And some of those would equally well use thorium or uranium, which at least doubles the potential fuel resource. And actually, I think your numbers may be a little small because, in fact, people are starting to think seriously of getting uranium out of seawater, which is a more or less infinite resource. So there are still lots of issues with nuclear power, but there are plenty of potentials to have both lower cost systems and inherently safer systems and a much expanded possibility of fuels. And there's a new MIT report that came out just in September which addresses this. So I'm sure you can find it on the MIT website someplace.
Fuel is only about 10% of the cost of nuclear power. So even if we had an infinite fuel supply, we still have the capital cost. We simply don't know what nuclear is going to cost because the generation 3 and 4 reactors, which look very promising, haven't been built yet.
All right, so Mics are being handed around. So, the young woman who's raised her hand.
Thank you. I love you more. First of all, I think we should congratulate all of you for being so engaged and using your wisdom when a lot of us have already retired.
I think
You're
it's
just
more that we
getting
just
started.
haven't let on yet.
Yeah. You all sound like you're just getting started. I wonder if I'm
Would you
not a...
introduce yourself.
Oh.
I think it'll be fun for everybody.
Thank you.
Yeah.
Gretchen Moski, and I'm a fuzzy, not a techie. So my comment is that you're kind of speaking to the choir. If maybe our new myth could be that the area, the city, the country, whatever, that adopt all this stuff will be the strongest, best remaining places, so that everybody, we've got to connect with everybody. That you make this report, and how many people, the government may agree, but what's to say what's going to happen next? Just a thought.
One of the, did you want to answer to that? One of the things that's really interesting when you sit back and say, well, what are the likely ways that impacts of climate change might play out? So some of them are pretty obvious. Changes in where you can grow crops, changes in how high you have to build bridges over waterways. But a lot of the more complicated questions concern things like what are at the roots of international conflicts? How many of the conflicts that are over resources have a climate change component? How much of the international conflict sort of spills over into regional or even global conflict? What are the sort of legitimate aspirations of people in the developing world, and how are they constrained? What's the immigration policy in the United States going to be for people who are resource migrants? And I think once you sort of step back and say, well, what's the full range of issues that we could be looking at? It's very easy. In fact, I think it's unavoidable that you need to transition from an individual who thinks of themselves as rooted at a given place and concerned mostly with the problems of that place, to really being embedded in a global matrix. We live in a globalized world, and that's not going to change. And I think that the fact that the world is so globalized means that the problems of climate change are going to reach us no matter how much we try and insulate ourselves from them.
I guess I inherited the microphone. I'm Bob Gould, class of '63 with her. But I think it was in 1974, Time magazine had a cover article about the coming ice age. And what are the chances that just about the time we finally get a handle on this, the natural cycles reverse and we're scrambling to go the other direction?
Yeah, so when we release heat trapping gases to the atmosphere, we also release particles. And we were really careless about releasing particles during the period from the 1940s through about 1970, when we actually had a overall cooling of climate. And the reason the climate cooled during that period was that these particles from sulfate, which were also a product of fossil fuel combustion, were having a net cooling effect because they reflect solar radiation to the atmosphere, was greater than the heat trapping effect of the carbon dioxide and the other heat trapping gases. Once we realized that there were serious problems that were being caused by all this SO2 for human health and the health of ecosystems, we started to implement regulations in order to pull the SO2 out of the atmosphere, both by changing especially what kind of coal got used for power generation and for making coal plants clean up. And the consequence of that is that, at least in the US, we now have a much cleaner energy system, but it's an energy system in which the intrinsic heating effects of the carbon dioxide and other gases come through. The mechanism by which carbon dioxide and other heat trapping gases trap heat has been well understood since the last decades of the 19th century, more than 100 years. Essentially, nobody has challenged the physics of that understanding that were laid out by the likes of Tyndall and Arrhenius in the 1900s. those, you know, scientists in the late 19th century, in 1896, Arrhenius published a paper on how much we would expect the Earth's temperature to warm if the carbon dioxide concentration in the atmosphere doubled. And he got about the right answer. There were a couple of small aspects of the problem that he wasn't completely right on, but we've really understood the underlying physics of the way these gases trap heat for more than a century. It's understood at the same level as, for example, you know, how a transistor and electric motor works. We also understand the major drivers of the natural cycles of climate. For example, 1992 was a cold year because there was a huge volcano, Pinatubo, that erupted in the Philippines and released a lot of these same sulfate particles that cooled the climate during the 40s. And we also understand that over many hundreds of thousands of years, there are wiggles in the shape of the Earth's orbit that have been responsible for pushing the planet into and out of ice ages. And we have a good understanding of where we are in the sequence of those ice ages. And the bottom line of all of what we understand about the natural cycles and the human forcing is that natural variation is occurring at a level that can be important on a year-to-year basis. We can still get a cool year, like 2008 was a cool year, but that we've now reached the stage where the effects of humans on the climate system are at least an order of magnitude larger than any consistent trends in the natural effects, and by most calculations about a factor of 100 larger. So I think it's actually very unlikely that there's a climate surprise out there where a natural cycle takes over. But it also was important to recognize that the concern about the coming ice age was related to exactly the same kinds of climate research that we've used to understand the fact that the planet's warming. And in the 1970s and 60s, because of the fact that we were being so careless about the composition of the fuel for the energy system, we actually were producing a climate that was tending to cool. I think what we didn't understand is how much CO2 we'd be releasing in the future.
Yes.
Yeah, I'm Karen Moxna-Steele, class of 1965. I'd like your perspectives on why the climate change deniers have been so successful in grabbing hold of this debate and influencing at least a substantial section of our electorate.
What's the motivation? Well, I don't know why the ball is tossed my way, but I'm happy to jump in. You know, there are several factors at work here in the United States. I can't speak as well to the dynamics outside the United States politically. In the United States, what we have is this extreme partisanship, obviously, that is, I think, really deeply, deeply hurt our governance processes at the federal government and state government levels. So the number of people in positions of leadership, elected or appointed public officials, increasingly are tied down by their party affiliations, and we know that that's happened in the last 2 years profoundly. It's happened before. So the search for finding something as important as this. So the search for finding something as important as the best science and the best judgments about science and the best steps to take have been thwarted and overwhelmed by, for example, yesterday's article in the New York Times catches it pretty well about the Tea Party. So the candidates of the Tea Party are really a profound effect, at least temporarily, for the Republican Party. That moves the entire party, as we all know, to the right, because if you have senators like Senator Bennett from Utah, who was an honest conservative and a sound science senator who tended to some degree to want to work across aisles and solve problems, he's immediately, loses his position and his important position in seniority in the primary in Utah, and everybody else is moved by that. The second thing is a lot of money. A lot of money is going into these anti-climate science campaigns. And as Chris said, unfortunately, the IPCC, in just some relatively small respects, and some people slightly in the interest perhaps of simplifying, overstated, or expressed themselves in ways that in retrospect created opportunities for those that wanted to challenge science and policy, and they exploited that. So I'm a big fan of the work being done in the National Academy of Sciences now. Ralph Cicerone is the CEO, president of that. He's a climate scientist. He was the chancellor at University of California, Irvine. I like, and Chris, maybe you could comment on this, the work that's increasingly being done through the National Academy of Sciences in the country, but it's really, really sound, important work. But I think, unfortunately, and I deeply regret this, that we've been set back some by these attacks in terms of moving public policy forward.
I think that's exactly right. I'd like to make just 3 brief comments. The first is that it's shocking to me that climate change should be a partisan issue. I mean, how could something as important as this be fall out along party lines? The second thing I want to do is recommend a new book. It's by a historian at UC San Diego named Naomi Oreskes. It's called Merchants of Doubt, and it's a incredibly interesting analysis of the skeptics movement in a wide range of environmental issues that includes cigarette smoking, secondhand cigarette smoke, the ozone hole, nuclear winter, acid rain, and then climate change. And there are 2 just incredibly interesting themes that run through all of those issues. The first is that it's the exact same individuals involved in every one. And it's mostly a group of physicists who were involved in developing nuclear weapons during World War II. And what Oreskes argues is that a lot of the motivation, or some of it was economic, and certainly if you are deeply vested in the technologies of the 20th century, it's going to be scary to transition to new technologies. But what Oreskes argues is that an awful lot of the motivation is actually an anti-regulation motivation, and that for a lot of these Cold War veterans, the passionate concern about communism kind of got transferred over to passionate concern about creeping over regulation in whatever context. So I recommend that. I'm not sure that I agree 100% with Oreskes' analysis, but it's a wonderful read, and it's just staggering how these same people were involved in all of the issues. And then, the final comment that's worth making is that climate change is a very different kind of issue than we've dealt successfully with in the past. And we're really talking about something where the impacts are far in the future, remotely far in the future in the context of 2, 4, 6-year election cycles, and where there are a lot of things that we still don't know. We need to make decisions based on evidence that is very compelling in some aspects, but very incomplete in others, and where the stakes are really, really high. And, I would like to hope that in human development that we had sort of, figured out how to deal with this kind of issue. But I think it's going to take some characteristics that we haven't tended to display. It's going to take incredible political courage and leadership. It's going to take real commitment, and it's going to take a willingness to step out of the normal way of doing business to find solutions that are going to play out over years and decades.
Can I jump in here just briefly? I mentioned earlier that one of the reasons for hopefulness is a lot of individuals have simply said, I'm going to fix this. And if you go back to the roots of what we thought our democracy was all about, it had very much the same kind of thing. So if we're going to fix this sort of merchants of doubt, it's going to be because lots of ordinary people are going to say that's simply outside the bounds. That's simply not true. That's simply not acceptable in our system. And we can all be part of that.
John, I don't know if you care for my Gottman-Unz metaphor, but isn't this the problem of American exceptionalism, species exceptionalism? It's very hard to build an old myth to demolish the old one. Thomas Kuhn wrote about that in The Structure of Scientific Revolutions, where the old paradigm people will defend to the point of being unethical, and maybe that's what the ClimateGate purloined emails were all about.
I just have a comment, and that is that I wish some of you were at the before lunch panel to deal with the public policy questions that were directed at people doing research on the effects of internet communications, ADVARs, on human behavior. There was an attitude of kind of thing, I don't know the answer to that question. I trust the democratic system to take care of it. Of course, these people were just excellent in their field. They're working among good people. There is such an emphasis at Stanford on social entrepreneurship. But somehow the rest of the world needs to be taken into consideration. Then one more comment. I know it's my business to ask questions, not express my opinion, but I think a lot of this anti-global warming doubters' belief is it's not just economic, it's fear of change, and the pace of change has intensified that.
I wanted to talk a little, I think that's right. So, Karen, getting to your question, of course, another area of concern and some resistance is the sense that taking steps towards mitigating or controlling or reducing carbon emissions, greenhouse gas emissions, will be extraordinarily costly. And Chris said correctly, you know, we need to find a balance on that. We can't decide that what we should undertake here is dealing with climate risks at the expense of growing prosperity around the world and a reasonable economy here in the United States. It isn't realistic to expect that. But what is striking, and that's what I thought I'd just briefly describe, is what has been done here in our home state of California, which is pretty striking. So in the work that I've done with the people of the Secretary General of the United Nations, I mean, we had one common agreement, and that is that what we recommended be done over the next decade or 2 decades had to meet the kind of economic test, that is, the least cost means to reduce the risk of climate change are the ones we certainly ought to prioritize first. And among those least cost things we've touched on, and that is investment in great technologies being developed at the great universities and great centers in the country, and the relative cost of that for what they may produce, swinging for the fences, as Secretary of Energy Chin has described this, is likely, we don't know in which case, to pay off with something a decade from now, say, that drastically reduces the cost and simplifies the changing of the energy systems, the transformations that need to take place. We don't know which one, but we can get there. But what I want to describe is what's happened in California over the last 30 years that is a story those that are close to this world know something about, but most don't. And I played a little role in this. I don't want to underscore what I did because there were so many people that contributed, but I was asked in 1979 to chair the California Public Utilities Commission because it was the time of the second oil price spike in the country, and we've just been through this water crisis in California. I'd had the opportunity to address that, by the way, through conservation and efficiency steps. So the obvious thing to do under spiking prices for oil, natural gas was a particular factor. Canada, in one step, increased by 50% its price of natural gas sold into the US, which particularly into California. So we looked at the incentives for the utilities in the state under traditional regulation, and it was clear that the incentives were wrong for the conditions that needed to be addressed. That is, we needed to have utilities in a position to take the leadership because they knew better than any institutions in the state of California who used what level of energy, what forms of energy, how much, and they knew it through the industries in the state, all manufacturing, all commercial, all individuals in the state. So we took a pretty obvious step, and that is we changed regulations such that the utilities in the state would not be penalized for investing in the least cost things that could be done, as well as the sound things as a matter of energy security, reduced dependence on overseas sources of fuels. And so the utilities then were directed, at the time when I was head of the Public Utilities Commission, with this to go forth for their customers and invest for their customers in energy efficiency to the extent it was economic to do that. And then what's happened over the last 30 years since that time, remember that would have been put in place by 1981 approximately. California's really had an extraordinary story. California's led in every respect. The utilities then, honestly, were put on the side of the customers for finding least cost solutions to the customers. The requirement in Stanford is that utilities invest to the full extent that energy efficiency steps, and there are vast, vast numbers of them, to the extent those are the least cost solution, looking at life cycle costs of the investment that would be made in electric system infrastructure compared with the investment that must be made in energy efficiency because it's not free. And so that has dominated California since that time. And so utilities, it was a great source of pride to us to go forth, and we stood side by side and all the time with my friends at NRDC. And we went to the state legislature and we advocated side by side tight building codes, tight appliance standards, everything that pertained to energy efficiency. And these were adopted and then improved about every 3 years, and it wasn't an entirely uniform patch. But the effect of all that is today, California still has zero increase in per capita energy consumption. So not any increase whatsoever since that time. Whereas the average across the remaining 49 states of the United States is 40% increase since that time. And I mean, these things are pretty simple to do. I mean, energy efficiency is harder to do than having one institution like a utility build a power plant or have a fully controlled system, because it involves everybody. It involves everybody. But incentives can be provided. So in this work that I've done with the Secretary General, we persuaded him to allow us to be made public our recommendations. And I won't go into them, but the essence of it, we concluded that at least for the next decade, the most important steps that can be taken are the research on the one hand and the energy efficiency initiatives on the other, and those are comparatively simple and they are really low cost. So what California has is the least cost means of serving, for example, electricity customers. They're in the lower cost approach because every time you invest in efficiency ahead of everything else, to the extent that's the lowest cost solution. So, yes.
So what do we as non-industry mayor mortals from Buncombe, Oregon do? Give me that one, Lynn, this is what you need to do.
Well, growing up in Oregon helps.
Thank you, John.
Other than that, I defer to my colleagues.
So what do we do? Do we get involved in investing in these companies, or do we get involved in public policy discussions? What do I do when I go home?
I think it's totally a matter of choice. If you like to help entrepreneurs invent new solutions, whether they're high-tech companies in the Valley or low-tech ones in India, plenty of opportunity to put money to work. And it doesn't even have to be lots of money in some cases. To build that rice power plant that I showed you is $40,000 per village. Okay, it's not real expensive. But I think equally, we need people to say, so they've done this in California, why can't we do it here? Right? And I think that's a very powerful thing to do. You can ask elected officials and those who want to be, why wouldn't we do that? And so I think it's totally an individual choice. But if I had a message to say, it's do something. Don't just sit there and complain at the television, right?
So I see we've got only 5 minutes more. Let's go real fast. I'm cutting off. I know other answers to that, but can we just go real fast? Who has a mic? And let's move the mics real fast. Okay. No mics.
Can I do have a mic.
Come forth.
I'm Marley Milton, class of 65, and I just wanted to ask some of you who are working on venture, how hard is it to get venture capital for the kinds of innovations you want to see? And is it possible to do that without big federal investments, or are those also needed? Thanks.
Short answer is it's hard.
Why don't we
and I work with several of these little companies. It's very hard.
Yeah, why don't we get several questions and we'll answer them.
Maybe that's a good way to do it.
Well,
so 3
John,
or 4 questions.
Lauren Dunbar. This is looping back to what you said, this great news story that actually, we don't hear these great incremental, savings news stories, but, this documentary, Who Killed the Electric Car, that was a big story in California, and who were the bad guys? The oil companies, who have so much vested interest in keeping oil consumption at the current level. So as much of an optimist as I am about our own individual initiatives as consumers, as communities, what do you do when really what you're going up against are the huge lobbying forces of big oil?
Well, I just say one thing, and that is California did over all these things over the opposition of the obvious people that didn't want to see them happen. And these things do happen. They go forth. And by the way, that initiative is beginning to be picked up. It's been picked up now in 9 or 10 states. For the first 10 years, nothing. So it was, I don't mean to say it happens overnight.
So why is it that there's never any questioning about, with Proposition 23, claims that this is going to be the end of the economy, and nobody questions on what basis do you make that, and it's a difficult thing. As a scientist, I have the same issue with Chris, that you say, well, this is the best model that we have. Nobody ever asks what modeling or what thing people did on the other side, but yet people are always willing to believe it. They never question on what basis that is. And any doubt expressed on the other side, it's just dismissed.
Could you explain Proposition 23?
It repeals
Yeah, well, the short answer is that it sets aside AB 32, California's Global Warming Solutions Acts, until there are at least 4 quarters where California has an unemployment rate less than 5.5%, which we almost never have.
Which hasn't happened in the last 30 years. So only one more, and then let's see. I was told I get the hook. Okay, last question, and then we'll go across the panel. I'll tell you what my answer to the question of what's one of the best things you can do, my friend from Oregon, I think that one of the best things you can do is talk to your children and your grandchildren, and the people that will really make a difference are the people that are students at Stanford right now, and Caltech, and a lot of those places, and I've had the opportunity to talk to several of those forums. We have to get those people to get out and vote, express themselves. They care. The response is enormous. So these things are going to take some time. It's regrettable. Wish they would move faster, but we do have to work on the public understanding climate. And I personally believe the public climate, it's where, Chris, you didn't hear me say this, but the reason I wanted to anchor this panel with science is if you understand the science and you find it credible and you go beyond just what I think in a group like this is probably a general higher level of being informed, but also a readiness to say, all right, I would move in the direction of what I generally understand. I think we need to have you understand this well so you can pass the message to others, because we have to move the public policy climate in the United States, and it has to be done other places around the world. Western Europe, as I think you all know, has a very, very different public climate, political climate, with respect to this issue. There, it's substantially, deeply, deeply felt and assumed that the United States is thwarting its leadership, is going absolutely the wrong way with respect to not recognizing this risk and not doing something about it.
John, what resources are available for us to actually engage in a grassroots education program across the country? Because essentially that's what we're saying we have to do.
Chris, maybe you, I could say some things, but I think you'd...
Let me just take a few seconds to comment briefly on this. What should we do, and then what tools do we have to do it? You know, I think the what should we do has lots of dimensions, but they all boil down to one thing. You need to make it a priority. It needs to be a priority in every consumer decision you make, in every investment decision you make, and in every political decision you make. And you know, so that's the individual foundation. And then the question is, how do you move the society? There's only a few of us, but society gets moved by thought leaders all the time. And I think that creating opportunities in the economy, you know, what we really need to do is create a level playing field. And then in terms of educational resources, John already mentioned the recent reports from the National Academy of Sciences. I think that they made a really big investment in making the material understandable and pointed to the interests of the people in the United States. And I think that the other thing that is really available now is a whole series of quite penetrating, educated, public-oriented books on the science of climate change, the politics of climate change, and the dimensions of the solution set. And if anybody wants to email me, cfield@Stanford, I will be happy to send you a list of the books that I consider to be the most interesting ones.
All right, let's close out by, I want to ask Bill, Al, any concluding remarks? Chris, anything you'd like to say?
Knowledge is power. The power of our Stanford education gives us the resources to deal with this marvelously complicated energy climate change nexus. With the effort that we used to put into a 5-units course, you can rise to the 98th percentile of awareness. And I think Chris's idea is wonderful. We need a syllabus, perhaps prioritize where you can start and work down. You'll feel a lot more powerful if you do that. We're all hypocrites here. The first thing you can do is never buy or use bottled water. And be absolutely squeaky clean in everything you do. It's a matter of attitude. Not that you're going to save the world by turning off the lights, but it's a matter of attitude, which then you impart to your grandkids. John talked about costs in the California example. California swims in the environment of all the other states and has to compete with them and then worldwide. So I'd like to know Chris's view on the need for, if it's essential, a worldwide carbon tax. Because we know the price of everything. We know the price of a gallon of gas and of our stock portfolio, but we don't know the cost of those with all the internalities built in. Finally, demonstrations are a very good way of showing what's possible and desirable and therefore hopeful, something that we can really vote for. And finally, we need to make a decision, and that comes from the Latin decisio. We need to cut away those things which are undesirable, which we do not believe, so that we can focus on that which we do believe. We need to make a decision about this climate energy nexus. Thank you.
And I'll just I'll just add one small thing, and it picks up that question that was asked over there. Increasingly, people at all levels of wealth in this country are starting to invest in line with their values. One of the names for that is impact investing. In fact, it's starting to change the way many foundations use their money. They're investing it rather than giving it away. But and particularly leading the way are family foundations that are starting to do this. I know nearly a dozen of these people that live within 20 miles of here. And in fact, I've financed this energy company that's doing rural health care in India and in other countries, largely on $50,000 investments from dozens of small foundations. And it's in the form of a loan, 2%, which eventually gets converted to stock if the lender wants to. And that kind of way to put capital to work in line with your values. There's a lot more capital in small hands than there is in big hands. You read about the hedge funds and all that, but the fact is middle-class America has much more wealth than all the hedge funds on earth. If it put that capital to work in line with their values and the things they decide are important, it would make a big change. So think about it the next time you look at your portfolio and your retirement account.
Thanks so much. I don't want to give any more advice, but I do want to thank all of you. The sense in the room of a real commitment to move forward, of recognizing that this is, you know, it's really the challenge of our generation, our century, and I think it's incredibly invigorating and inspiring to be in a group like this that really clearly is bringing a combination of thoughtfulness and resources and dedication and optimism to bear. So I want to thank all of you.
So that's it. I'm just going to ask for another round of applause. I couldn't feel better about having persuaded all these folks to come forward. Thank you very much.
For more, please visit us at stanford.edu.